Hello and welcome to the channel, and to the second stage of my Homebrew UnRaid ThreadRipper build. In this video we'll be ripping apart my current UnRaid box and replacing the motherboard, CPU and memory with an ASRock Phantom Gaming 6 X399 motherboard, AMD Ryzen Threadripper 1950X and 32GB of DDR4 memory. Pretty much straight away I ran into a problem. A simple task of removing the Zotac RTX 3060 from the PCI Express slot, not usually something that is a problem. Once I had made a little more space around the RTX 3060, I had another go at trying to release the tab that was holding the card into the slot. I really did not want to snap off the tab on the end of the slot, or cause any damage to the GPU. And after a couple of attempts, I moved on removing the SAS controller and PCI graphics card. Eventually, after much faffing and not really getting anywhere, I decided that the best option available was to just remove the motherboard with the graphics card still in the slot. Now that I have the motherboard removed from the case, I have a lot more space and I can get a good look underneath the card. So I just need to push forwards on this tab here with this little small screwdriver, and we should be able to release the card now. Lovely stuff. Pop! Out she comes. I'll just replace this memory module I need to remove to gain access to the ATX power connector, and we should be good to just give this board a little boot test now that it has been safely removed. The graphics card I'm going to be using for testing is an EVGA GeForce GT610, which unfortunately for the time being is the GPU that I'm going to have to be using for my UnRaid ThreadRipper. Which unfortunately for the time being is the GPU that I'm going to have to use in my UnRaid ThreadRipper build, as the Phantom Gaming 6 motherboard has no integrated display. I'm going to pick up a cheap, passively cooled replacement for this card in future, so this is just a temporary measure. Wonderful, so the system is posting fine. That's good to know that everything is still working, albeit needing a good clean and a new CMOS battery. Right then, back to the build, and as I stated in my previous video, I have purchased a brand new Corsair CX650 power supply to power the new hardware. That means stripping out the old one, so while doing so, I might as well talk a little bit about why I decided on an upgrade when my previous setup had been working out brilliantly. Well, it had, up until a certain point. You see, everything appeared great until any heavy network traffic was encountered. My virtual machine would begin to suffer with tiny amounts of lag, which largely affected the audio. This led to me scouring through MSI mode utility, which you can see here, trying to figure out whether the lag I was experiencing was due to devices being on the same IRQ. Some devices were sharing the same IRQ. The Intel ICH9 family USB host controller and ICH9 family USB 2 enhanced USB controller were both sharing IRQ 10. An ICH9 family USB host controller and the NVIDIA GeForce GTX 980, which at the time was the graphics card I was using, were both sharing IRQ number 5. So to change the IRQ from the NVIDIA GeForce GTX 980, we just tick the box MSI, apply and reboot. After a reboot and the settings applied, I ran a video here of Gran Turismo and a program called LatencyMon. LatencyMon checks if a system running Windows is suitable for processing real-time audio and other tasks. LatencyMon analyzes the possible causes of buffer underruns by measuring kernel timer latencies and reporting DPC and ISR execution time, as well as hard page faults. It will provide a comprehensive report and find the kernel modules and processors responsible for causing audio latencies, which result in dropouts. It also provides the functionality of ISR monitor, DPC monitor, and hard page fault monitor. In my case, I was having latency issues with my system, and even repeating the MSI mode utility and changing the IRQ of the USB host controllers, the latency issue still prevailed. This left me with no real answer to what was causing the issue, and for the time being, I put up with the latency issues. Although LatencyMon was showing that my machine was having issues with audio playback, most of the time the experience was perfectly acceptable. And I will just give you a little example here of Transport Fever 2, a game I've been fairly addicted to, you could say. The minimum system requirements for Transport Fever 2 are an Intel i5-2300 or an AMD FX 6300 processor, 8GB of memory, and an NVIDIA GeForce GTX 560 or an AMD Radeon HD 7850 with 2GB of video memory. The recommended system requirements are an Intel i7 4770K or AMD Ryzen 5 1600 processor with 16GB of memory, an NVIDIA GeForce GTX 1060 or an AMD Radeon RX 580 with 4GB of video memory. And as you can see, it's running fairly well. We're not getting any stuttering really within the game itself. It's only usually when there's heavy network traffic, so I can live with that. Also bear in mind that this was running on my old system, dual Intel E5 2440s clocked at 2.4 GHz and a Zotac GeForce GTX 980 with 4GB of video memory. So we should see a significant improvement in gaming performance with this new build. As we are flying along on this train, out of the window you will see that a new power supply has been fitted and a Phantom Gaming 6 X399 motherboard is now being snugly fitted into its new home, and from this point on the rest of the build should be fairly straightforward. Reinstall the SAS controller, the temporary and slightly noisy EVGA GeForce GT610, followed by a final card populating slot 2, fully populating all 3 available slots, is the Zotac GeForce RTX 3060. That is the build complete for now, and in the next video we will take a look at some benchmarks and see if the virtual machine experience has improved using much more modern hardware. Thanks for watching and take care.